First of all, who of you have actually heard of Couchbase before? Oh, that's actually a lot. I'm amazed. That's like the most I've ever had so far. So, yay! Okay, so first of all, for those who have not talked to me yet, so I'm Philipp. I'm a developer advocate at Couchbase. So now we are called developer advocates. When I started, I was a technical evangelist, then I was a developer evangelist, and now I'm developer advocate, so don't care about the title. It might change next time you meet me, so just try to remember my name. Okay, so I'm going to talk to you today about actually a real full stack talk, how it came to be, because we're going to go from displaying something in the web browser to actually using Node to build a REST API, which uses Couchbase as the backend, and then, which actually was the second talk, going how is the Couchbase driver actually implemented in Node, which is on top of C++ and extending some V8 and C library. Okay, so first of all, yeah, if you want to build a REST API, you most likely want to use JSON and JavaScript because, well, it's all we know and love, obviously. I don't have to tell you that. And one of the important things is responsiveness. So responsiveness in this case, I don't mean like I can shrink and extend my browser window, but actually like having a really fast response time because, well, actually I think Amazon made the study like every millisecond it takes them longer to deliver a page, they lose a lot of people. And also I talked to a guy from The Guardian, which is an English newspaper, and they actually spent the last 8 months optimizing their CSS to shed, I think, like 60 millisecond load time on the CSS. But it was actually, he said, in the end it was worth it. They actually made money on the project because they have so much more page impressions now. So yes, responsiveness is really, really important. Also, if you get, because your website is so incredibly fast, you get more users, you also want to actually be able to scale with it, and that's also another strong focus of, well, this whole talk and how we can achieve it. And also you probably don't want to rack up 50 servers to handle 50 users, so you kind of want to be effective with your resources. So that's just to give you a quick framework on where we are, and now to actually how do we get there. So yeah, it's a Node.js meetup, so I don't have to tell you anything about Node, you all know that. One important thing maybe is that if you use something like Couchbase, you most likely want to develop your API with like really loose coupling, so you can easily rack up more node processes or scale down node processes. Because actually, I mean, just scaling is always about the two dimensions. So you don't want to just be able to scale up because then, well, if you don't have users all the time, then you waste money. But you actually want to be able to scale both ways. So remove servers if you don't need them, and add servers easily if you need them. So that was what AWS was all about in the beginning, and probably still is. So yeah, keep that in mind. Couchbase, which you might not know that much about, except half of you. So the strong focus for Couchbase has really been delivering a sub-millisecond latency for, well, most requests. And by the sense of most requests, I mean like there are certain like quite complicated queries, but for the normal queries you do every day, which are most likely key value, you get sub-millisecond response time. Like even if you request a lot of keys, it should stay well below 1 millisecond answer time, and that's really important because it allows you to do stuff by actually applying quite advanced key patterns, which maybe you need to fetch multiple keys in succession to emulate a more complex query. But since every key query by itself is so fast, it allows you to do this really nice. And it's also designed to scale, sense of scaling out by, well, the web interface, I think it takes like 3 clicks to actually add a server and probably also 3 to remove one. So that's really the point. You can like really easily, and then you can also automate that obviously, but you can really easily add nodes and remove nodes. And one of the probably most prominent examples for that was actually the app Draw Something was backed by Couchbase when it was released. And they went from 3 servers to 30 in, I think, just 3 weeks. So they I don't know if you remember it, so I think they scaled down a lot, hopefully, because nobody plays it anymore, I think. But at the time it was quite popular, and it got quite popular really fast. Also, Couchbase is quite efficient. So by efficient, like, well, a lot of people say, like, oh, I started up and it takes over basically my machine and I can't do anything anymore. It's not quite that bad, but it like grabs all the resources it has like right from the start. But that's really the point. So it has a certain set of resources which it's going to grab at the start and which you assign to it, and it tries to use those as efficiently as possible to serve the most requests, but it's also going to stay at that amount of resources, so you can count on that. So a little bit more, well, Couchbase is a document database. Yeah, we all probably heard of document databases, MongoDB, and so forth. But we can also store some different data types. So we actually have a native counter implementation. We can actually do increments, decrements. Well, that's based on numbers. We have special string support, so you can atomically append, prepend to strings, which is sometimes really useful if you, for example, want to build a quick list in memory or something. You can do this really easily by imagine a separator and just append with that separator, and we have special support for JSON. Okay. Yeah.
Do you store documents more than 16 megabytes?
Yeah, more 20. But yeah, there is a limit in there which is 20, but it's a compile time limit. If you build your own, you can make it bigger. But the point really there is that most likely the problem is if you store like really large documents, if you remove a node from the cluster, you suddenly have to shuffle a lot more data between the nodes because the data is not going to be as nicely distributed across the cluster. Some are really large. But there's actually a project which is called Couchbase FS, which allows you, which exposes an API which then automatically splits the documents into multiple parts to keep them at, I think, 4 megabytes max, and it splits them apart so it easily shards them across, but exposes it as one big document, basically, on your way back. So if you need to do that. Okay, so JSON, yeah, we all know and love. JSON in Node.js is insanely simple. You probably know that. And JSON in Couchbase is about as simple. So this is just a screenshot from the web API, web interface. It has direct support, so you can, like, theoretically, you can go in there, edit on the fly, as long as the JSON is not too large. There is a very odd limit of 2.5 kilobytes for one document. If above, the web interface doesn't display it, you can still like do stuff with it, but the web interface doesn't display it anymore. So it was in there because some of our clients still use really old browsers. And if you send them a too large of a JSON document, they just plainly crash. And, well, they don't like that. Yeah, so Couchbase JSON is a native data format. We have special support for it. If you store JSON, it gets tagged as JSON, and we analyze it more deeply. We also allow you to do actually more complex queries on it. And those complex queries are called views. So who of you has worked with CouchDB before? That's way less. That's even more surprising than the first. So CouchDB, well, it supported, or it still supports, it's still there. It supports map and reduce function, so you pass it a JavaScript function, and it generates an index over all your documents. And since Couchbase actually uses the same file format underneath, you can use the same view query engine that CouchDB had, or still has, And we ported that over, and it's actually a lot of the same people who actually work on that. And so we can expose the same API for views as CouchDB has. By now, most of it has actually been rewritten because, well, for speed reasons. But the basic, well, it's still compatible protocol-wise. So yeah, just to give you a quick demonstration, this is how it would look like. You have a lot of documents, cool, you can view them, and they have certain properties. You don't need to read that, but there are like they have a type on there. And now you can create a view, you give it some name, and yeah, actually this is a view just to count all, to see like what's there. And if you show the results, well, okay, we have a list of like, those are all the documents which are currently in this bucket of data. And if we now decide, okay, we only want to count the ones which are of a certain type, and the type is just an arbitrary property on the JSON. I call it type, you can call it whatever you want. And we can then say like, okay, only index those which are actually of the type bar in this case. And if we save that and refresh, we get like, okay, we get less because those are of type bar. And now we can actually use the reduce function. In this case, I used count. I could also use, well, there are some others built in, and it tells you, okay, there are 2 of type bar. There are a couple more built-in functions, and you have a lot more options on how to query. But this is actually a really powerful system. Not so much for actually doing like live queries, but for like doing stuff, well, like maintenance work, for example. We recently had a client who had to do some cleanup in his database, so I wrote a view, which was actually quite complex. It's like 300 lines of code for just the reduce function, and the map function is about 100. And so it figures out a lot of stuff about the data, and then actually allowed with a really simple script to clean that up. Yeah, so if you need more JSON, I always use that in my examples. You can easily grab JSON off GitHub if you need huge, or well, pretty large JSON snippets. And if you want to display it in the browser, that was actually for some other guys from the Java meetup. I put that in there because they might not have known. Yeah, so okay, JavaScript is great, we all know that. And now to actually show what we're going to do. So I built this little application where we're basically going to walk through. So it's a really simple app, which, well, let's make it a little bit bigger. That's a little too big. So much for the responsive resizing and so forth. So yeah, so you can, it's basically a little questions and answers app. So just to walk you through it, and then how I built it from ground up. So okay, so we have a couple of questions. So this is just a list of questions, and every time a user checks something, we obviously save it off, so I can actually refresh my page, and my data is still going to be there. Normally, it's a one-page application, and it supports multiple users, and it displays like, okay, how many users answered a question in a certain way on this slide. So this is actually one thing where I used views for, and I can also tell you why. It also supports user login and so forth. Okay. And the main part about that is really building an API. So the technology I used was obviously Node, Couchbase, because it nicely allows me to use JavaScript all the way through, and a really small snippet of, honestly, in the beginning I thought I would need more Angular, but, well, I didn't. So the Angular part is going to be really, really small. Okay, so first of all, users. From most of you probably know this is really simple Express. You have a sign up, you get the credentials, you create a user, and you store it in the database. Okay, that's all nice. And you're obviously saving the session because otherwise you would be logged out. And for sign in, well, equally easy. you grab, you get the credentials from the body again, check, okay, can we authenticate a user with that? If yes, then all is great, and we save him off in the session and redirect and so forth. Okay, cool. So for that to work and actually not lose all our data when we restart our application, we need some database. So yeah, okay. So how do we use Couchbase from Node? So to get started, like really quick example. This is how you would start out. So you obviously have to require Couchbase. You create a new cluster, which the cluster is basically our top level thing, which contains all the nodes. And then you open a bucket. So a bucket is just a bunch of data. And you can think of it kind of as your database in MySQL, which can then have like a lot of different tables. In our case, a lot of different documents with a lot of different types. So the bucket is really about resource allocation. So you say, okay, this data, I assume that it will be about, let's say, 16 gigabytes overall. So I allocate a bucket which has 16 gigabytes of RAM allocated to it. So I know that its working set will always be in memory, so I can actually have really fast response times. And then I can actually use this bucket to store and retrieve data. So this is the new API. It's highly inspired by other document databases. Before it was more Memcache-like. So now we have like insert and upsert and get stayed the same. And okay, so really easy to store that. So if we look at that again, and I decided not to type that out all the time. Yeah, okay, so, yeah. Okay, so what we see, okay, we get something back, and there is like the first thing you might actually notice, and I'm going to go into more detail on that later, is you get back the value, obviously. That's the bottom one, because you stored that. You might want to get it back. And you also get this chars value, which is actually an object with two parts, 0 and 1, and then a large number. And we're gonna go into this, into those internals a little bit later, since I merged the two talks together. So yeah, so you get back those two things, and those are the ones which you need to work with later on. So what do we need to do? Okay, so this is the old API. This still works, but now you would use Couchbase open bucket, cluster open bucket, pass it a configuration, get back a bucket, and this is something you should then keep around, because Couchbase uses the concept of a smart client. It abstracts away most of the things you need to know about managing connections, which is really nice. So you don't need to do any, opening multiple connections to multiplex over those. This is actually handled internally by the driver. It also reestablishes the connection if it should ever go down, because actually we don't have like one connection to one node. In this case, I think I opened the connection to localhost. But what actually happens is you open the connection to localhost and you get back a description of the whole cluster. And then at that point, the client establishes a connection to every node in the cluster where it needs to get data from. So you don't like ask the same node all the time, and this then asks in turn another node. That would obviously, especially if you're really performance sensitive, this would slow down your requests probably too much. So what we do, we actually determine, okay, we know that, for example, for key A, node 1 is going to be responsible. So we already have a connection to node 1, so we can ask node 1 directly, get back the value for key A, and save ourselves a lot of time. So since this is obviously quite a long process, actually the establishing connection is like 4 requests, I think. So You don't want to do this like on every request because then it would, well, your whole performance would basically be gone. So most of the time it's just like you encapsulate it in a little module or function and use it as a singleton passed around all over your app. Okay, so that's good. And at that point, yeah, we need to store our user, and there's where keying becomes quite, well, important or at least interesting. So most commonly, you have something which is unique to your data. In my case, for user login, I assume that the user that his username is actually unique. If it isn't, then I'm going to throw an error because, well, I'm not sure how I would manage login afterwards. Otherwise. So I can actually say, okay, cool, I'm just going to use his login as my key. One thing most people do, and which is highly recommended, is that you actually prefix your keys with something you know. For example, for user, prefix it with you or user or whatever, because, like I said before, we're going to have many different types of documents in one bucket. So there is the opportunity for a clash, especially if you use something like a number for your key, then, well, there are going to be two things with the number 5, then you suddenly like either overwrite weirdly your data or you tell someone he can't do something because something else already happened. That doesn't make any sense. So most of the time we prefix our keys so we can actually make sure, yeah, and I know I want to log in a user, I'm just going to take what he gives me, prefixes with a U, and can go from there. So this is kind of the predictable keys. If you can do this, that's really great, because at that point you can just do a straightforward key value query, which is fast, so all good. But what if you want to now allow for the user to actually log in via multiple different sources? So for example, his email address as well as his Twitter username, and I think I had like Facebook in there, which is again a number. So what's really the thing to do there is have referential keys. So have one key which points to the back to the main document. In this case, I said like, okay, I'm going to be able to log in via my email address as well as via my Twitter username. And when I fetch those, all that the key is going to contain is just the key for the main document. So I have to do that, and I have to do 2 fetches. I first fetch like, okay, issue for my Twitter username, I get back use Phil, and then I fetch my main document. Okay, so that allows me to actually have a lot of different things. And so at that point, okay, now we need to actually look a little bit more into the code and see like, okay, how are we going to create a user at that stage? Let me make this a little bigger. Okay, so when we look at search, wait, there we go. So what do we do when we create a user? So this is what was called. Okay, we get a user, we have his credentials. That's actually not interesting. It just saves off the credentials, and then we call user save. Okay, so what does save do? At that point, we hash the password, because you should always hash passwords, obviously. And then we call db.add. In the new API, that would be interchangeably with db.add or db.insert. Well, db is my bucket in this case. And what that gives you is if the key is already taken, it will throw an error. So it basically gives you a unique constraint on your key, so you don't have to like build that yourself or do my stuff there. So that's good. So we now can actually create users without ever having like usernames clash. And the db.add or the add function or insert is also used quite often to avoid other clashes, like avoiding email clashes and so forth. Okay. So good. We are actually able to create users, and now we need to authenticate them. So first, I'm going to show you like what's on the Node.js Express side. Okay, so we have a user. We actually get a session ID, and we validate this ID. So the session, I didn't show that in here, but the session should obviously be encrypted and signed and so forth. But what you get is basically the key of the user in the database. And what validate does, it loads this complete user in. And in a lot of like applications where I worked on before, you wouldn't like necessarily load the whole user on every request. Most likely you would maybe ask a cache or something. But since Couchbase actually basically is a cache already built in, there's no need for that additional layer. So you can actually just say, okay, database, just give me whatever that is. If you find it, great, then this is a valid session. If I don't find it, then okay. Well, I guess that's not a valid session then. Somebody tried to fake something. Okay, so at this point we get to the actual game. We need to store away data. We have our questions, we have our list there. So how do we actually get this? So it's quite easy. We have a question list per user, and every time you're going to get this, we're actually going to return a JSON stringified list of those questions and answers and all the data that belongs with that. And we also make sure the user is authenticated, obviously. And the other side is, well, if we actually modified something, then we post there, again, check auth, and save whatever has been changed. And in this case, Angular will then take care of actually managing the changes client-side. And, okay, so we have that question list. Let me show you the small part of the code real quick. Actually, equally easy. So I'm actually loading the question list just from a file. Don't have that stored away separately. And one nice thing, well, I'm actually just overriding the toJSON method to make sure I actually only store away the questions, and because I store away, I have some additional parts in the document normally. And the more important part is actually the load. So I take, okay, all I do, I have this key which is based on the user ID, and I can then load it off. And at this point, I do one thing, which is actually, you see here, you remember the CAS value from earlier. So there is, I'm just saving away the CAS value to use later. And I'm going to go into this just really quick. So remember that the CAS value is saved basically with the loaded list. Every time a list is loaded from the database, I actually have the CAS value, which is, and you can now think of it basically as just as a 64-bit value. It doesn't matter what's in there. It actually shouldn't matter. And we also, which we're going to see later on, we're also going to use a view to actually get the counts for all those questions. Okay, so that's from this side. And now that's into why we have this weird CAS thing. So, oh nice, good job, PowerPoint. So, in our app, in this app, it's probably not that highly likely, but still, there might be a user which is like or we have some other app which is highly interactive. There are going to be lots of users operating on the same document, and you don't want to accidentally just overwrite stuff which somebody else did without actually ever knowing. So what the way to solve this in Couchbase, there are actually two ways. So first of all, you could say, I lock the document and don't let anybody other access it, which then, well, if it's like highly concurrent, you have, first of all, you have the overhead of actually locking and all that stuff. The other version is use this CAS value. The CAS value is just a value with every time you write to the database, it changes. It's not a hash or anything, it's just per document an ever-changing value on each write. It doesn't change on reads. So if I read it and I have saved it off, and then my actor 1 comes and stores a document again with this cas value and provides the cas value, it's going to say, okay, that everything went fine, you loaded it before, it hasn't changed in between, you can save it. The second actor comes in and he loaded it at the same time as actor 1, but now actor 1 saved it, and actor 2 tries to save it, and at that point you're going to get a cas mismatch and says like, okay, the data has actually changed since you loaded it. You might not want to just plainly overwrite whatever was there, but most likely going to read again, merge your changes with what happened underneath, or maybe you did a set of operations on the thing which you can just replay, depending on what it is. So you do that, you then save it, and well, if there's still a cas mismatch, you repeat, but most likely it doesn't happen a lot. So because the requests, like I said, they are really fast. It highly depends on like how much time you're going to spend in your application. But even under like really heavy load, we hardly see that there are a lot of cas mismatches. So this is actually the way faster option in most cases. So okay, in this case you can't read any of that because it just like meant a lot. But this is just my question list actually. So what I do, like I said, I save off my cas value, and the important thing is on the save I actually provide it as well. So if I just do a db set or now upsert or update, and I don't provide it, it will just override. So you can still, if you want to, you can just override it. Nobody's going to stop you. But if you provide it, then it will actually check if you have up-to-date data. And this allows you to have consistent data. So Couchbase is consistent within a cluster. It allows you to have consistent data, like know what you're going to write, what you read, so forth, without doing like more complicated merging on read like we would do, for example, with Cassandra or React and so forth.
And how do you handle that?
What do you mean? Like,
so basically, if you get the same, you must merge data. So.
Yeah, I mean, but you don't have like you don't like from the database. You're only ever going to be provided one version of the data.
So
where in React you would get provided more. No, you only get like there is your database is a single source of truth. So there is one version of the document in your database.
Yeah.
There's never going to be two. Like in React, if you store something and somebody else stores something, then if you request the same key afterwards, you get back two documents instead of one which you expected, and you then have to resolve at read time, where we basically resolve at write time and then have a single source of truth in our database. Does that make sense? Or?
Yeah, but what I still don't understand if multiple users are basically editing one document, which data will be stored? How do you merge that you know that? Well,
it highly depends on what kind of data you have. Like for example, if the most simplest case would be you have an array and you store product IDs in there. So normally, if you say like, okay, user A reads it, and right now there's just one in there, and user B reads it at the same time. He reads, okay, both read. There's an array with one. One adds 2 and one adds 3. They write back without any locking. One of the requests is going to win, and you're going to either end up with 1-2 or 1-3. With using a cas or optimistic locking, the first one's going to write 1-1-2, and the second one is actually going to get a cas mismatch. He has in his memory, he has, okay, I have 1-3, and what I got back from the database is 1-2. So at that point, I have to resolve that for my write. What I did. So you have to
merge.
You have to merge, like depending on what kind of operations you do, obviously. You have to merge or consolidate whatever the writes was, but you actually get at write time, you get the response like, okay, you can't write it like this because you're going to overwrite data.
Do you automatically get the current data back when you get the cas?
Yeah. You always read. You're going to get the data and the cas value. That's always, you're going to always get it in this like tuple of value plus cas value.
Question.
Yes.
Is it possible to register a callback on a cas value change? Kind of that I get notified?
On a, you basically want to get notified on a write.
Yes.
No, not right now. I mean, internally there is an API, and we are working right now on how to expose that, but it's not officially supported yet as an external API. Because the problem is that you might get, depending on how many writes you have, you might get an insane amount of notifications. Because right now you would just get one stream of like every change. You can't like filter, I only want for those 3 keys or something. So this is what we are working on right now to make that like more easily manageable. Okay, so AngularJS, I think most of you know it. I actually just mainly have this slide in there because of which I find the best description of something ever, which is model view whatever, for in the browser. Okay, so all I'm going to use that for is rendering really simple responses. So, like I said, I expected to need more code, but I actually didn't, which is kind of nice and also kind of bad for you because you don't see more code. But actually, that's all that is. I listen to all the changes and save them back, and that works. In the beginning, I thought like, okay, well, I might have to like do more stuff to like deduplicate and so forth. But actually, that worked well enough. So you can really easily just listen to all the changes on this object and then render it out. The rendering is really just a little enhanced HTML template, which I can hardly read my site, that's a problem. But yeah, I guess you've seen some enhanced HTML templates, so I'm going to leave it at that, but I'm going to show you one more thing, which is actually showing the answer count, because that's what we have left out so far, and that's really one of the important things as well, which is the Couchbase views. So just to give you a quick idea how that works, and then you also see like why to use them in certain cases and why not to use them. So let's say we do any storage operations, like our sets, updates, whatever. They're going to be stored in RAM cache. So most of the time we operate solely on the RAM cache, and then they're going to be asynchronously replicated to other clusters. You can define like, okay, I want all my data to be replicated at least 2 times, so it resides on 3 servers in total. And it's also going to be asynchronously written to disk. And yeah, cool. So if that finally happens, then what happens in the current version of Couchbase is at that point, the indexers can pick it up, because it's the CouchDB file format, and then they generate the index. So this is quite a long change. It actually doesn't take that long, but there is going to be a delay between I write something and it shows up in the view. I can modify that a little bit. I can pass certain flags and say, okay, I don't want like that much staleness in my data and so forth, but this is what's happening right now. In 2 weeks, this actually cuts out, so it's actually, the views are going to be straight from RAM as well, so that makes them a lot quicker and a lot more responsive. But there's still going to be a delay, obviously, because it's just going to take some time to run JavaScript or Erlang over JSON to create an index. So, okay, so what does a view look like? We've seen it before. It's just like, in this case, I create my map function, which picks out the different questions from my question list, and then sums up the different answers. And if we store this design doc, which is called design doc, so it can hold actually multiple views, we store it away and we can afterwards query it. So what is querying? We already saw that. So okay, so we create a query, which is a connection view, which returns your query object. You have to tell it which view to query and which options you want to have. So you can actually pass certain keys which you want to query. You can group the query like you would your normal SQL query. And you can also say, like in this case I said stale false, I don't want any stale data in my view, but that was just for demo purposes. And if I query it, I get back a lot of results. I get back actually a list like, okay, this key was in there 5 times, this was in there 4 times, and so forth. And I can just display that then. The whole point really is that due to, well, it's set as eventual persistence, it's like it might take some time till it is persisted, or at least till it is picked up by the indexer. There are certain things where you want to use the views for, and certain things where you don't want to use the views for. So, yeah, operating persistent data, still not for very long. So it's not a good idea to use them for login, because your user might type in his, well, he might register for your service, be really quick, or your service might be under high load. He tries to log in and it says like, oh no, your user does not exist yet if you query a view. So at this point you should always use, well, basic get and set value queries or insert and update and so forth, because they actually, you read your own writes always. So you can use it for all the data which can be stale. For example, this answer count, nobody's going to care if that answer count is off by 1, because, well, actually nobody's going to ever know. Also, if you have something like comments on a blog, if the comment count is 10 or if the comment count is 9, again, nobody's, well, you might realize, but it's like not a major problem. And again, then there's quite a small difference we're just going to introduce you. So we have, like we've seen earlier, there's development views, and now we've seen production views. So there's quite a difference in there that development views, if you create them as development, they only run on one machine. So I've seen this like trip off a couple people because they expected way more data, and then there was like, oh, there's so much missing. Well, if it's just a development view, it just runs on one server, and whatever data that server has, it's going to be indexed and returned, not of the whole cluster. So also, just as at production time, it's actually then going to be scattered all over the cluster, and the whole data set is going to be returned. So keep that in mind. The main point of development views is really to be for development. Yeah. Is that okay? Couchbase 3.0, which is coming out in 2 weeks. Then we're going to have a lot faster views, so not as much of this delay between. Actually, before, when I was using a really, earlier I was using an old version of Couchbase on my laptop accidentally, and I actually had a lot of time where I clicked around, and the answer count was actually wrong a lot of time until I refreshed the page, and then it was correct again, which is like, okay. And also, if you don't want to use views and don't want to write JavaScript for that, there's also a query language which is currently in developer preview. And that was it for the first part, and now we're going to dive a little deeper in the actual source code of the driver. So we have the connection now. Where's my... We have our connection now for Couchbase. What's actually happening underneath, and how does that work? So, who has written C modules for Node before, or actually extended Node through C, C++? Okay, cool. Nice.
Right, so not.
Yeah, I guess you still remember. Okay, so C and C++ in Node. Why would you do that? So why would you guess would you do that actually?
It's faster.
Thanks, that was what I was hoping for. Actually, most of the time you don't gain much. You might gain a little bit, but if it's really well optimized JavaScript code, it might be about as fast. This is actually, I stole that from Felix Geisendorfer. That was one of his, like, okay, I can get my MySQL driver about as fast as the C bindings version. So yeah. Of course, we're going to use it because C is really, really cool. Everybody wants to write C. Sadly, there's no JavaScript version in there. So yeah. Well, some people really like writing C for everything. I personally, I don't, but it's decent for what it is. But what is actually really, really valuable, if you have a C library and you want to use it from Node.js, and there is the option to use, there's a FFI, a foreign function interface, which in benchmarks for us at least, developing CouchNode, it added a lot of overhead and was actually really, really slow for some reason, and it actually wasn't that much easier anyway, and was quite hard to debug. So what we actually did is, what we actually used for CouchNode is, we have libcouchbase underneath, which is a C library which abstracts away most of the complicated stuff which you have to do, and provides a nice, more simpler API to manage that, and that's across most of our SDKs. So, except Java and .NET, all the SDKs underneath use the same C library, which also means we have more resources to actually throw it at that. And then there are just wrappers around that, like, for example, CouchNode. Yeah. Gonna leave that out, but I didn't have that earlier. Quick, just a little bit of history. So, Couchbase is often mistaken for CouchDB, or we are like said like, oh, that's the same guys or something. It is kind of the same guys, but the heritage is actually Memcached. So there were guys at Sun and Google and so forth who wrote Memcached, which is a really great caching server, and then there were the guys at Zynga who decided, oh, well, it would be really cool if we could use just that for our database. And if we wouldn't have to, like, if we don't lose data every time our Memcached server crashes, and so forth. And also, like, cluster it and, yeah, all the stuff Zynga does to make really fun Facebook apps. And from that, there was Membase, which made a persisted, clustered memcache server. And out of that, it's actually where Couchbase comes from. And the CouchDB guys provided, well, the CouchDB project provided the storage format on disk, as well as the view engine. But the clustering as well, most of the clustering, as well as most of the API is actually Memcache or Membase. Okay. So there is a strong focus on performance from that. That's really what the.
Do you have any information? Did they ever lost any data?
About what?
Did they lost any data ever?
Zynga?
Yeah.
Probably. I assume.
If there is no any disk.
There's no what?
If there is no any backup.
Well, what Membase actually did in the beginning, they took the really simple route and had an SQLite per server. So every time you wrote into Memcache, it picked it up and wrote it to a SQLite file on disk. But
it makes sense.
If you are writing really heavily to a SQLite file, that's not as stable as you would expect, especially if you write if the file grows to a couple gigabytes, then SQLite doesn't like it for some reason. No, it was a problem that for them, actually, the startup, when SQLite has to read in all the data it has on file, it takes a really long time because the file can be badly optimized depending on how you've written. Okay, yeah, so we've seen that before. I actually want to skip that, but yeah, I can skip it. Oh, yeah. Okay, again, we've seen that as well. Yeah, same example, but so this is what we're going to see. Okay, so we require it, we connect to the cluster, that's great, and at that point, really, the require, it basically loads a C library, which with some functions wrapped around it, and some extensions written in C, C++ for V8 to do that. Okay, so when you first dig into this, what happens? So if we look at the code, okay, we have this bucket thing we just opened. So okay, I looked a little bit when I first got in contact with CouchNode, which quite some time ago by now, but this is almost how it looked like. So okay, I dug into because I actually had a bug to fix. It was missing some functionality. I was like, okay, so how do I get to this state where I can actually interact with this database? Okay, so there is this CBPP instantiated, which gets then all used all over the place. But where did it come from? So looking at the top of the file, we see like, okay, there's this binding thing required, and this binding thing contains Couchbase impl, and this is where our Couchbase PP comes from. Okay, cool. So where did that come from? So looking at the Couchbase impl, it seems like, okay, this is where we actually in C land now. So we start to see like stuff like, okay, there's this NaN scope, and we have different functions. Okay, so yeah, I don't expect you to read that, but this is like where I was like, okay, I probably need to find a better way to like show that like what kind of happens in a C library before I go deeper into that. So okay, so Hello World extension. Let me just show. So can you read that? Cool. Okay, so for that, we actually need a couple of files. Jip is a build tool which is used in Node, or it's actually used to build Node itself. And so what we're actually going to do, let me just go to the index file, which is empty for now. So actually don't mess up. So we're just going to create a hello extension. So we're going to require, so much for the not messing up. And so, okay, I already know that it's going to be in build. You see that I saw the directory already. And it's going to be in release and hello, because this is what we're going to call our library. And all this thing should do, it should log, it should basically just return a string. So, hello world, and I want to see that. So this is most likely, especially if I remove the build directory first, this should not work, obviously. And I say, okay, first of all, I can't load the module, and I can't really do anything. Okay, so I also have Node.jip already installed. So Node.jip, you can grab that as well by through most package managers, or actually through npm, I think, as well by now. And if you tell it to build, well, it's actually going to throw an error because, hey, there's stuff missing. Okay, so what's missing? If we look into this, Node.jip expects a JIP file, which defines, okay, how how is this extension, what does this extension contain, and what do we need for this? So this is just by convention, it's called binding.jib, and this is JSON, so it's going to have a lot of targets. In my case, actually just one, but it could have a lot of targets. And we required hello. So one of my target name should be hello, because this is what I want to load later on. And we're going to have some sources. I already created a file which is empty by now, but it's like hello cc. So I'm going to say like, okay, this is my source file. And if I now run Node.jib, it's going to say like, okay, it's going to say there is a mistake in the file because I forgot curly brace. If I now rebuild, it builds and builds and builds. And so I was like, okay, that even worked. Okay. Is there anything still in the hello? No, the hello CC file is actually empty. Quite surprised that it can actually build an empty thing. But yeah, it obviously can build an completely empty module. But that module says like it can't find that, but it actually means like there is this hello which we just compiled, which contains nothing, doesn't define a module. So yeah, we need to actually define a module in there. So we do a hello. If you go into our hello CC, and I need to, so we need to, first of all, yeah, we're going to write a node extension, so we're going to need node.h, so the node header file. And we also going to need, because we are using v8, we also need v8.h, obviously, because it's again a header file, and header files define a lot of the functions. Well, it defines like basically the functions which you can call from the C file. So to make my life more easy, I'm actually going to use the namespace v8, because most of the stuff you're ever going to do in Node will be in the namespace v8. So either you can just prefix almost all the stuff you ever do with v8 : v8 : or you just say like, okay, I'm going to use this namespace and yeah, make my life more easy. So now we're actually going to define a node module, and this is where this comes in. So node module, this is just a macro which actually allows you, now I can define, it actually defines a module which is exported, which we can then require. Okay.
One question.
Yes.
Does this use a V8 heap, or it's because you mentioned the performance, it's mostly the same, and I'm wondering, how's it possible? It doesn't share the same memory. If you move objects between node land and native C land, you have to, depending on what kind of object it is, like for example a string, you have to actually wrap it in the V8 object and then ship it back, and it gets, well, it then becomes a JavaScript object which you can access in JavaScript. So the problem really, like performance-wise, the problem you have with most times where you use a C library is that, well, C libraries won't operate on native V8 objects. They will actually operate on, yeah, they will actually operate on well, C structs or objects, C++ objects. And this wrapping and unwrapping is actually not as cheap as you would like. So it actually, if you do it in JavaScript, and if you have good optimized JavaScript code, it can be as fast because it stays in it stays in JavaScript, it stays in the V8 the whole time, and it doesn't have to do the wrapping and unwrapping all the time. That's where like a lot of the performance penalty really comes from, and this is like also what the guys in Node have been working on for quite some time to improve that.
Makes sense because it has to initialize all the time the new object.
Yeah. Yeah, it also has to register it because for garbage collection in JavaScript as well. So yeah, you have to actually do a lot of stuff. Okay, so at this point, okay, we have this Node module, and the second parameter I provide is handle to an init function. So we say like, okay, this just defines like we have a module, but what we actually want is we want to do something with it. So you can call it init, you can call it whatever you want really, but you need to tell it. Init is a common name, I guess. And it actually tells you like, okay, it has a target, which is the context it's going to be initialized in. And, well, at this point I could just like do nothing, but this would be boring. So I say like, okay, I'm going to define this one method I have. So I do a node set method, and it says like, okay, on my target, which is now my node module, I'm going to define a method world, and I'm just going to map this to a C method, which is also world, which I now need to define. So this means now my module, which is basically a JavaScript object, has a property, which is a function, which is called world. So now, actually, my VI complains that world is not defined. So, okay, let's do this. This function should return something. We want to, well, in my really simple case, I just want to return a string or, well, something I can log to the console. So, and in Node or in V8, this is always, if you pass something around, it's always passed around by a handle which contains a value, which you can then access. And now something which JavaScript programmers will actually know, so there's arguments. And so your function, because like JavaScript doesn't know, like in C, you could now maybe see like, okay, it expects an int and expects a lot of different stuff, for example. But in JavaScript, you can just pass an arbitrary amount of arguments around. And well, that's not really a thing what C or C++ was really built for. So you have to jump through some hoops to actually get to your arguments if you want to get to those. I'm not going to do this now because I'm just going to return something, but for every argument you want to actually access in your function, you have to extract it from this argument, well, from this argument object thing. Yeah. Okay, so what we're going to do now is we have our scope, which is the thing we run in, which contains basically the world of our Node.js program. And in this scope, we want to return something we can print to the console. So in my case, the most easy thing you can print is actually you create a string and you return it. So this means at this point the function returns, and it returns with this new string. And there you actually see how, so the double quotes would actually be the C or C++ string, but to make it actually able to pass it back to the V8, and V8 actually to do with it, you need to wrap it in a, like we are using the V8 namespace right now, but normally this would be V8 string new. So we actually have to create this separate V8 string object to deal with that. And at this point, if the demo gods are with me, should actually be able to rebuild this, and yeah, it still builds. And now, we actually get our hello world. So this is the most complicated way you can print hello world. Well, you could ship it over a network, but this is one of the most complicated ways to actually print hello world in Node.js. And it's also probably the slowest, but that's just due to the generated overhead. So you can find all this, by the way, later on. But now comes what we hit, a really fun part. So this was Node 0.10. Now we are moving towards 0.11, and everything changes because they decided to change a whole bunch of the, well, V8 changed a whole bunch of the APIs. Node changed a whole bunch of the APIs. So yeah, that was actually Couch Node in the beginning was actually just written in plain without like any more abstractions. That was a bad idea. Luckily, somebody else did a lot of work for us already. So there is a project which is called Node Native Abstractions, which is just a huge file of C++ macros, which allow you to create strings and detect like, okay, is this 0.11 or is it 0.10? And then create the right string for it and so forth. Using it, I'm not going to type this out now, but using it is actually really simple. So you just add it to your project, so it's a Node module, and you include it as well. And at this point, you can do this. So you might not see a lot of difference right now, but okay, there's this nan return value, for example. So return values, which is like one of the things which is used most often by any function, actually changed its complete signature between 0.10 and 0.11. So yeah, now there's actually a more abstract way to do this. And all you have to do is like, okay, include nan.h and use it. Okay, so what could go wrong? Like this is kind of straightforward to actually do this. So to move on to something more complicated, which is actually going to show more stuff, is I decided to like, is anybody familiar with Murmur 3? It's just a hashing thing like MD5 and so forth. And it's implemented in like a really fast and really nicely to use C library. So I decided, okay, I'm just gonna wrap it in a little thing and see what happens. Well, this is one of the most, well, this is C++, but this is like one of the most unhelpful warnings and compiler errors you will see. And you Google it, you find a lot of, because you can actually Google it for it, because it has appended things to the beginning and end and so forth. But what it actually means, you can actually find it, and it means like, okay, you're using a C library, which is, again, Couch Node is as well, and not a C++ library, so you have to tell Node about that, or you have to tell the V8 about that. If you actually use C, which happens, I think, like, especially wrapping stuff, it's more likely going to be C than C++. So keep that in mind, that trips up a lot of people. So, okay, in this case I'm not going to type this out. So yes, I created a little module, again, just to see how it was. So we have this, I called it Murmur. It has Murmur and the special version for x64 128 bits. And I'm going to pass it in some data and the seed value, and I expect there to be some data returned. And well, because we are in Node, we want to use that asynchronously, so we actually have a callback. And this is how you actually, at this point, nan method is the new form of how you define method, because that's also changed to 0.11, but you can just think of it, this is just a C method. And this is how you actually access the stuff in the arguments. So you have to, you get an arguments object, or something like an arguments array, and then you can actually extract everything you need. You have to extract by hand, but it's not that hard. So you can there are multiple extractor methods. For example, a U in 32 value. I expect the C to be a 32-bit integer, and I expect the callback to actually be a function. So my arguments at position number 2 I actually expect to be a function. And so, well, this is not actually asynchronous in this case because I didn't spawn a thread or anything. But what I now do is, okay, I call in my library. This is just the function to call in my library. This just gives me something where I can actually store the data in. So I call in the library and let it do its work, and I return a result. So every time you call a callback, you should always have an arrow first and your value second. So we're going to create a result, which is a value with 2 items, which has null because we didn't have an arrow in the first, and a buffer, which is just the way to hold our hash data in the second part, and we have to, because we're in C, we have to give it a length. And now we can call our callback, and this is how we call the callback from C++ and V8. So you call the callback, return the result, and our function overall returns undefined because we don't care. Okay, so now to finally go to some couch node. So what actually, I'm just going to explain through this real quick, what's actually going to happen on a get. And we should now be able to understand that. So get is the same as, gets to actually stayed the same. So get is a get. So what we do is we have this fn get. So this is internally mapped to the get method of our object. We're first gonna grab our this. So this is the object unwrap implementation. So we get back a pointer for this. Okay, this is like our instance. We're gonna also create a cookie which is there to save us some data, and then we're gonna extract all the arguments we need. So this for get is going to be a key, and there's going to be some flags and all that stuff. So we're going to extract all that, and we're also going to get the cookie, which should also contain our callback. And since this is a C library, we have this handle to our connection. Like I said, a connection to Couchbase is a singleton, which you should only create once, and this is what we do. We hold it internally and get it every time we need it, and then we can actually call values on it. So we do a LCB is libcouchbase get. We get the handle to what actually our library is. We pass in the cookie, which contains also our callback. We say, okay, a 1 is, in this case, it's just a flag, and the command is also, okay, this is it contains a couple more flags, like, what does it contain actually? It's like TTL and stuff. So it's like enhancers to the command, and we return like, okay, this command has actually been sent, so we return true. And libcouchbase, because it's also built on, it's actually also built on libuv, as is Node. It can nicely handle our callback and call that for us. Actually, wrap it, if the callback is correctly formatted, and wraps all the stuff. So you remember maybe from the beginning there was this cas value. It looked kind of weird. It's this object with 2 properties, 0 and 1, and each containing some number. And if you read on the forums, everybody says like, oh, you should never pass that around because that just doesn't work. And this is why.
this is what we actually get back is a 64-bit integer type, cool. And what we do is we create an array from that and just act as the 64-bit integer type would be two 32-bit things and just assume like it's two things, so it's going to be split. We don't even make a real array out of it, so that's why it shows up as this object with two properties. And we just return this to you, because this is the fastest way to pass that object around without us having to do so much to like make sure that it stays in the way or like serialize it to a string or whatever. So this is why this cas value looks really weird. Okay, so that's mainly going to be it. If you still have time to break our software, so you know some of the internal stuff, and maybe you find something. If you break it, a lot of people will be really mad, but you will get money because we try to release in 2 weeks. So if you want to, you can go there. Also, if you're interested in more about like scaling stuff and scaling software, I'm the co-organizer of a conference in London. It's not too far away. London is just 1 hour flight, 1.5. So yeah, you can stop by if you like to. What?
2 months, 1.5.
Yeah. So if you want to stop by, you still have time, and if you're interested, talk to me afterwards, and you can get a discount code as well. Okay. Any questions? And also, all the stuff is in good time. Yeah, that was it. Thanks.